Hey there, algebra. Miss Carly here. We are in lesson 4. Um, yeah, I'm currently recording this as we're going through the first few days of school. So if you're watching this not year 2020, I'm kind of tired. Okay, it's been a long day, but I know it's going to be great, and I'm looking forward to learning lesson 4 with you. All right, so Unit 1, Lesson 4, we're going to talk about the shape of distributions. And I would always recommend you taking notes while you are going through the lessons. Okay, remember we've talked about being an active learner versus being a passive learner. You definitely don't want to be a passive learner, all right? Just not as cool. You're not going to learn as much. It's not going to be worth your time. I don't want to talk to you just because I want to talk to you. I think that you want to take this time to really learn what we're learning, all right? Let me push pause so I can find the right page. All right, first let's do a which one doesn't belong. Again, when we are face-to-face in the classroom, these are the best. I also love the notice and wonders too. Talking about which one doesn't belong and why. Like, which one doesn't belong and why do you think? Well, looks like here I have a shape that goes like that. Here I have the opposite shape as A. So B looks like the inverse. C, that's a straight line. And then D, it looks a little pushed off to the right. So really we have many different reasons why we would think that one of these doesn't belong, like I said. Okay, kind of a bell, kind of an inverted bell, straight across, very boring, not a lot of change, and we call that skewed. All right, we've got more vocabulary words to learn today. So we could say that, I'm going to write some things down for you to remember. You can jot the notes down with it. A, it doesn't belong because it's the only distribution with most of the data clustered near the center. All right, we could also say B doesn't belong because it's the only distribution with very few dots near the center. All right, I'm going to go back to B. There's a word I want to teach you, or a term. It's a bell-shaped distribution. Okay, vocabulary word. And B is actually called bimodal. Bi is a prefix that means two. So when we say bimodal, can't spell bimodal. That means we have a peak over here and a peak over there. Okay, two peaks. Sorry about that. Didn't mean to move my head. Two peaks, bimodal distribution. And if I go back to C, which one doesn't belong and why do you think it would be C? Okay, it doesn't belong because it's the only distribution that has the same frequency. For each value. Okay, we call that a uniform distribution. Okay, uniform distribution. I just stopped for a second. So I think I finished everything with C. Let's look at D. Why do we think D doesn't belong? Looks a little funky, right? Goes over to the side a little bit. So we can say that D, it doesn't belong because it's the only distribution that's skewed. It's the only distribution with skewed. Yep, it's the only distribution with skewed data. So it goes over to the right a little bit, okay, up like this. So it's the only one with skewed data. All the data has pushed to the right more than everything else. Okay, we call that non-symmetrical. Non-symmetrical data. All right, good job. All right, so let's look at part 2, matching distributions. Now, in your classwork, in your student task statements, it may say 4.2, matching distributions. Well, I already know I'm in lesson 4, so it just says 2. All right, and that's okay. It's all right. All right, so the purpose of this is to give us all a chance to practice finding data displays that represent the distribution of the same data set, okay, using really precise vocabulary. Vocabulary is really super important for describing the shape of the distributions. Okay, so if we were in class today, I would be distributing some cards, all right? So let me prep that so we can mess with it. First of all, what do we notice and wonder about these two data representations? Okay, what do we notice and wonder? All right, it looks to be the same data represented in different ways. All right, it looks to be the same data represented in different ways. I'll erase this highlighter in a minute. But if we look at this horizontal number line, 79 through 95, again, 79 through 95. This looks to be skewed, right? And this looks to be skewed. Okay, so it's the same data represented in different ways. Just erasing all the fun stuff. All right, so if we were in class today, we would take turns with your partner matching two different data displays that represent the distribution of the same set of data, okay? So I'm going to move us over to a Google Doc so that we can play with that a little bit. All right, we're going to play this game in class, hopefully. So if we don't, sorry, something must have happened. But if I see you, we're going to play this game, which is what it was talking about in the matching distributions. So it says arrange students in groups of two, display the images of the dot plot and histogram, ask the students what they notice and wonder. But I'm going to do this with you virtually first, and then when I see you face to face, if we're face to face, we will hand out cards, one deck per table, per person, and you can play with it. But we're matching distributions. Match each dot plot with a histogram that uses the matching data. Okay, so, I mean, there's things we're looking for. There's a lot here. I tried to make the Google document, and it just did not work. Okay, this is, in Desmos, how we match. Okay, that did not match. So if I look at this number line, I'm going from 99 to 199, and it's flat straight. Here I've got a flat straight one, but it goes negative 19 to negative 9. This one, like here, looks like it might match. So let's put them together, and it hooks them together so that we can just set it off to the side and deal with it later, right? Now, let's see if we can find another one that is straight across. No. To match this one. What about this one underneath here? Nope. There's so many cards in this deck. It just was, the Google document got so messy. All right. Nope, we're looking for like a negative 19 to negative 7. That is basically straight across. 19 to 17. Ooh, 19 to 17 holds 1, 2, 3. So 2, no. And then 17 to 15, 1, 2. I don't think that's it. All right, so let's not look for that one. I don't think these are supposed to go together. I don't know what happened there. So I'm separating them. Okay. Oh my goodness. Too much. It won't unhook. This is terrible. There we go. Let's see if we can find one more, and then I'll stop. Ooh, I like that one. There's my matching one for this. So I want them both to highlight, and then I'm going to move it aside. And look, it tells me that 2 sets are correct right there. So I got those 2. Get that out of the way. See if we can find a histogram to match that dot plot. It looks like it's skewed to the right a little bit. So let's see if I can find a histogram that is skewed to the right. I know I can't see them all. That one's bell-shaped, negative 19 to negative 9. That one might go with this one. Let's see if I can make them highlight. I can't. There we go. 3 sets are correct. All right, I'm going to stop there so that you guys can play tomorrow, okay? But that is the essence of 4.2. Now, some notes, some things that we want to pay attention to. Let me get back to, oh, no, we don't want to be dragging that around. All right. All right, so for each set you find, explain to your partner how you know it's a match. Well, we're going to look at the number line. We are going to look at the shape of the distribution. I wonder if I got them closer. Nope. I wonder if it's because my earbuds are connected Bluetooth too. I'm going to try that. Hold on. Maybe there's too many Bluetooth things. So shape of distribution. What else? So shape of distribution, and we're going to look for bell-shaped. We're going to look for bimodal. Remember that one? That's sort of like a U, where it looks like this. When the distribution was even, distribution or flat. Airbud's definitely not helping any. Skewed. So those are the things we're looking for to compare. All right, so we'll talk about that more in class tomorrow, and that'll be a lot of fun. Next time I see you, not necessarily tomorrow. All right. So then this next part, your teacher will assign you some matched distributions. Using the information provided in the data displays, make an educated guess about the survey question that produced the data. Be prepared to share your reasoning. Let me gather this together. Actually, before we do that, let's look at this really close. This is another Desmos activity that has to do in the next part of the lesson. So it's what I was handwriting in the piece of paper, not paper, whatever. What type of distribution do these models represent? Select all that would apply. So if we look at this shape, it looks very symmetric. It looks bell-shaped, and if I look at this one here, it's bell-shaped too. I think it's uniform. Yep, it's not skewed and it's not bimodal. All right, let's see the next one. I think it's symmetric, not bell-shaped. I think it's uniform. It's not skewed and it's not bimodal. I don't think this one's symmetric. It's not bell-shaped. It doesn't look uniform. I think it's just bimodal. It actually looks symmetrical, not bell-shaped. It looks uniform, not skewed. I don't know if it's bimodal, because bimodal is just two peaks. That one in the middle, I think that makes it not bimodal. Let's check though. Wow, so we have two peaks on each side. That makes it bimodal. No problem. Okay, not symmetrical. It is bell-shaped, but skewed, and that's it. All right, so let me check one more thing. All right, so this is the last part of the lesson. Where did the distribution come from? So looking at this data, using the information provided, make an educated guess as to what the survey question that was asked to produce this data. I don't know. It's very even, right? What would we guess for this one? $99, $100, $101. There's 2 data points for each number. What do you guys think it would be? I know, it's so hard. I'm guessing high temperatures on some really nice island in July. That might work. Okay, we're not going to get a right answer for this one. What about this one? I've got -19 to -9. Low temperatures in a very cold place in February. Makes sense. And this one. What would the question be asked that would get this one? How many spelling words a 4th grader got right on the first day back to school? Okay. Ooh, I didn't want to do that. This poor child, whew, rough day for him. Everyone else did pretty good, right? All right, I think this is the last one. Nope, that was it. Okay, that was all we had for today. We're going to play a card game tomorrow, and it's going to be fantastic. Not necessarily tomorrow, but soon. Good job.